Hello everyone, welcome to the project Mangrove. This is Uğur. In this video, I will review an error report generated by FindSecBug static code analysis tool. I will show you the error report on Mangrove website. On the right, click on the label error reports tab. You will see this tab after you complete the training and pass the quiz. So this is the error report that we will review. Click here to see the details. This is the command injection error report. We can read the details of this error type on MyTrace website. So this error report was generated for Carniac parser class of Stanford Core NLP program at run Carniac method and at line 165. So now I will show you this file in my Eclipse IDE. So this, as you see, this benchmark is already imported in my workspace. I will click on Ctrl-Shift-R and paste the class name. So this is the file that we will work with. I will go to line 165. Here, this error report basically says this usage of process builder can be vulnerable to command injection. What this means is that FindSecBug thinks that this argument is not something that we can trust on. It is basically we call tainted. That's what FindSecBug thinks, and we want to make sure that that is so. So this is a list of strings with two objects in it. One is parser executable, a class member. Other one is the infile. A parameter to this method. So first I will look into this infile object, infile parameter. For that we will find who calls this method. Right click on the name of the method and you will see open call hierarchy. Here we see two usages of this method. First one here in get k best parsers. It is this infile object, this parameter, and we see it was created here. And we can say that since we are not getting any parameters from outside, we can say that this creation is safe. There's no possibility of malicious users injecting any command queries here. So this creation is safe, and then we don't see any dangerous operation, any unsafe operation that allows malicious parties to manipulate. Therefore, we can say that this usage of this Carniac method is safe. Then I will continue to the second usage. So by the way, we don't have to go deeper into here because we know that these parameters do not interfere with our error report. They are not used in this call, Carniac call. That's why we can stop here. We only want to make sure that this parameter is safe. And here we see that it's not coming from outside parties. It is created in here and passed into the current Carniac method in here. Alright, so I don't need to go deeper. I will go into the second user and I see the same scenario here. It is a local creation and then used in this run Carniac method. So now I will go back to the position of the error. We made sure that this parameter is not tainted, and now we need to make sure that this parameter, this class member, is safe too. I mean, if it is not safe, then yeah, there's a real command injection vulnerability in the code. So this is where it is defined. The initial value it gets is Carniac bin, which is this hard-coded string, is the static final string, and we see that this object is private, which means it is not manipulatable, it's not modifiable outside this class. So here, move the cursor on the name of this method. On the right, you will see this transparent rectangles. The light yellow ones are the places where we modify, and the gray ones are the places where it was used. So this is the only place it was used, and this is the place which we know is a hard-coded string, and this is the place where it was modified again. So we see that it is the second parameter of this run Carniac parser. I will do the same thing here, open call hierarchy. So it was used, it was called in here. So I'm interested in the second parameter. First parameter do not interfere with our error report. The second parameter of this call is the first parameter of this method. So the code in here is safe, but we need to make sure that the methods who call this one are safe too. So here in the parse method, we create this Carniac parser annotator. We are interested in the first parameter, the model, which was defined in here. Alright, so yeah, and then it's only used in an if condition check. So it was defined in here. It is getting some property value from the properties object. So what we will do now, instead of going further into if this property is safe, we will search for this property key value in the project. On search menu, text project. There we go. We have 41 matches. So this is, for example, one match. It is a .properties file, and we see that this is a string which was defined by developers. I mean, it's a part of the project. It's not coming from an outside. We don't consider this properties file as an outside resource. It is part of the project. And what we will do now, we will select all the occurrences and extend this tree further to the deepest levels of each branch. So that, because we can see the usage, the particular line in this view already. We don't need to open each file at this point. So we see that these are all property files, and these are all hard-coded strings defined in the property files. These are all property files. So here we have a test, a test case, which is creating this part model as this constant string. Again, since this is a constant string, this is also safe. A safe test case, even though it's test case, it's safe. But yeah, if we see some test cases asking for user input, for example, then since it's the test case, it's not actual part of the project, we can say that we ignore the usages in test cases. All right, this is again coming from properties file. We here open IE servlet. We set the property to be this constant string. Actually, there is something we need to look into. This data dir should be safe too, because if data dir comes from outside resources, then it is actually a possibility to inject commands there. All right. This is a deparse. This is not our key indeed. We get here a usage in here. See, this is just as part of a string runtime exception. This is get. Again, this is properties file. These are all properties file. Here there is this println, which is just a print statement. This is, what is this? This is where we create the properties. All right, so we need to make sure that this default parser path is either this one or this one. Either way is safe. So moving on, get property, runtime exception, document.java. This is safe. This is set property parser model. Let's have a look at where does this parser model is coming from. Sorry, if it's not null, it is set. This parser model is defined in here. Yeah, this is args. This might be something that is coming from outside resources. Yeah, this is the main method. So here we have user arguments is set to this parser model. So this is a very typical usage. You give this configuration option -parser model, and then you set the string to be the parser model. At this point, this is actually a real vulnerability, because one can set this configuration option, and after following this configuration option, one can give a command which is designed to inject into the terminal, into the command line terminal of the system. So this part here, this parser model is not a safe object. It is reading a value from arguments and outside resource. So that this set property here is not safe. Now what we also need to make sure that is this sentiment pipeline is actually reaching out to this parse method, because even though we are creating this pipeline properties, it might be the case these properties are not used in here. It might be just a module of the software which is allowing users to run in command line and setting the properties in command line, whereas this usage is for example library usage, where the properties are read from a file, just like in here. So this is one thing we see as suspicious. Let's complete this review first, complete this list first, and then we will look back if this pipeline, sentiment pipeline Java, is used in annotator implementations. If there is any possibility of data flowing from this sentiment pipeline class to the annotator implementations class. All right. For that, let's first complete this list. We see that this is just print. Yeah, we have actually completed the list. We only have this thing needs to be verified. If this parser model value is the data that this variable is holding reaches out at this point, then we do have a real vulnerability. For that, what we will do, go back to this call hierarchy and look at the places which calls this parse method. So we see these three callers. So this method this map is consuming a string and returning a function, this parse method. So yeah, this is where we call this parse method. We call it with props, but where this props is coming is it's actually input this function. This is an example of functional programming, and here in get we have the same example. We have this empty props. So parser model is not defined in here. What will happen if it is called, this parser is called from this method? We will see this model is null. So we will throw an runtime exception. Let's have a look at here to verify that. These empty props do not include parse.model. Yeah, it doesn't. So going back to that location, this usage is not creating a thread, again, because this parse empty props does not include parse.model. Let's have a look at the second usage. Here we have this props object. If it is empty props or single sentence document, if it is either of those, we will get default parse. Otherwise, we will get the props, which is the parameter of this class. Now, what we will do here, we will call the call hierarchy here, because this get method, since this is returning a function, we will not see the callers of this get method here, but rather this get method was called inside this run parse. So we will look at where this run parse was called. All right, this is getting deeper and deeper. We see it's called in 4 places. First one is this props, which is actually consuming another props. Second one is in here, run parse props. It also takes props as the argument. All right, yeah, so we need to look into deeper each of these branches. Here we have coref. So this coref is actually in this branch is called with this default props, which is actually empty props. So this call is safe, we don't need to go deeper into this branch, because at this point we are sure that this default props object is not coming from outside users. It's hard-codedly defined in the project. I will look at the second usage here, which is again this brand KBP is have its own parameter. Here it is safe, again it's with default props. Here we go deeper, the props are coming from here with default props. So this branch is safe. It's in all cases it is using the default props, which is something hard-coded in the project. So let's look into deeper in here. Here in this parse, again we use it with the default props. So I will go to the next usage. Okay, there are lots of callers of this run dparse. Here we call it with properties, default props. I think this is the same path that we earlier looked at earlier. This is also calling with default props. This is default props too. So this branch is safe. This coref is safe. Let's look into this dependency graph. Here default props is safe. Here default props is safe. The props is a parameter here. We will go deeper, but nobody uses this method. So again, even though this property is set using this graph dependency, but there is no function, there is no other places which uses this dependency graph method. So what could happen in this scenario? A user of this library, this framework, might set dependency graph with this properties value that the user creates, but at that point it needs to make sure that that creation is safe. So it is a responsibility of user of this framework to be sure of injection to this method. So at this point we will say this dependency graph method with properties parameter is something that the users need to be careful about. But if users are writing their code in a way that allows malicious parties to inject through this path, it is not actually a vulnerability in core NLP framework. It's a vulnerability in the code that they write. That's how we interpret these kind of situations. All right, moving forward. So what we said here, these calls are all safe. We will look into the properties in here. We have this call with the default properties. So this one is safe, this one is safe. This governor method branch is safe. Here again we have default props. One level further, same situation. The governors class can be used as a library function, and the users needs to make sure that they do not allow injection into the system. Moving on, this branch we have here using the default props. Here again default props. Moving on, here default props. Again, users of this library function, library method, needs to make sure that malicious parties cannot reach out to this resource. Here we have default props. Here we see again default props. So as you see, we are going through all of these branches to make sure that there is no input coming from outside resource. Here we go deeper, and as you see, we see default props at this point. So I'll close this branch too. This branch is safe. The last higher level branch is this one. So first three branches are here safe. There is no places where we get user input or outside resource as input, and pass it as a property to the run parse method. Now I will look at the last branch. I see this run sentiment method. Sentiment is called with default props. So at this point I can say this run parse method, wherever it was called either with a safe argument or it was called by a library method. It was called a method which is going to be a library method which needs to be taken care of by the users of this library. All right, let's go back to the point where we had the suspicion. So we wanted to make sure that this pipeline properties do not reach out to this part of the code, and for that we looked into the places where called this parse method, and one of those was the getter and setter. So this one was one of them. This parse method was one of them. Yeah, this parse method was another one of them, and we made sure that this prop is safe object. So let's actually create the call hierarchy at this point here again. Here we had the callers of parse. We had 3 of them. This one did not appear in any place. This one was empty props or default props. This one was safe. And for this one, we looked into the places which call this run parse method, and they all turned out to be safe. So this usage is also safe. And so, which means there is actually no point where we use this pipeline properties. We are passing this pipeline properties as an object into this parse method. So there is no path from this line of the code reaching out to this line of the code. So even though this parse model object getting a value from user, that value is never used at this part. For that reason, let's remember how we came in here. So we were looking into this parser model, and we made sure that this parser model is actually coming from the properties file which are part of the project. And we were looking into here. So this parser executable is coming from the value of that is coming from the properties file defined in this project. Therefore, in this error report, we already made sure that this in-file object is safe. And now we also looked into this parser executable class member. We see that the value that it gets is always coming from the .properties file or the default props object, which is a hard-coded property list in the Java files. All right, at this point, this was a long code review. At this point, we made sure that this arguments object does not get any value from outside resources like users or HTTP cookie. Indeed, this is a hard-coded object. This object is created locally in the project, and this variable gets its value from the properties file. Therefore, this error report is a false positive. Now I will go back to the Mangrove website, say, no, this is not a real vulnerability, and explain briefly here why I think this is a false positive, which I will explain as this process builder object gets an argument which is a string list, and there are 2 strings in this list, and each of these string objects are created locally in the project. They do not get value from any outside resource. And I'll put in here how many minutes did I spend here. For example, this one was probably 20 minutes of my time. Then I will submit the label, close here. Now I will not do it because I will refine my explanation at this point. So that was how we review error report. We used this call hierarchy view a lot. Other than that, we use this search text project functionality too. And another thing we use a lot is control click. which actually takes us to the definition of an object there that we are looking at. Control click or command click in macOS. So important things to look at are the types of the variables or class members. This one is, for example, a private member, so it's not going to be accessed in other places. So another thing that we look at is these small rectangles here. Light yellow means there's a modification, gray means there's a usage. So this is a usage, this is a definition, modification of that class member or variable. And that's basically it. Remember, we expanded the search results here. We didn't open each file here, and because we can, for example, we can see what's happening at this file. It is actually a string value that this property key gets. So that concludes our review. Thank you very much for listening. We will have more review videos in which we will cover some different scenarios. Thank you very much. Have a wonderful day.